average value of a function is something that's probably easy to think about conceptually, but it might not be the easiest to find a formula for it. So if we had a function that looked like this, and we wanted to say on the interval from a to b, so this section of it right here, what is the average value that it takes? Well, it obviously goes, in this case I drew an increasing function, but we have some point here, f of a, we have some y value here, f of b, and it's between those, and that's the min and the max. But you can see that depending on how your function curves, it's not usually going to be exactly in the middle of those two necessarily. So how you can find the average value very simply is turn this area that's under this curve. Turn this area into a rectangle. So how do you do that? Well, to find the area of the curve, you need to do the definite integral. So by doing the definite integral from a to b of f of x, that gives us the area. So what we're saying is we want this area to now be a rectangle instead. Well, the width of the rectangle should still be from a to b. And whatever the height of this rectangle is, that will be exactly our average value of our function. So we're going to set this equal to the area of a rectangle that has a width of b minus a and a height of h that we don't know. This h right here, that is the average value of your function. So, for example, I redrew this here approximately. This y value right here is the average value of that function over that interval. So to solve for h, obviously, then all you need to do is divide by b minus a. So we get h equals the area of the area under the curve divided by the width of your interval, and that gives you the average value of your function.